We use Philips Hue smart bulbs in our house. They communicate with this hub to access several features, and some of our bulbs are even old enough that they don't have Bluetooth, so they require access to the hub. Ideally, we want the hub in a location central to all of the bulbs. And since our bulbs are spread out around the house, that means we want the hub as close to the center of the house as possible. The center of our house just happens to have this adorable little nook that has both an outlet and an Ethernet jack. This little corner also happens to be our kitchen counter, so it'd be nice to not have a big pile of cables sitting on it. I can hang the hub on the wall, but the cables still dangle on the counter. So it'd be nice to have something to wrap the cables around. I designed this mount that sits between the hub and the wall. I designed the back of the mount to mimic the back of the Hue Bridge, and then the front of the mount is designed to interface with it. So this sits between the Hue Bridge and the wall. And then you've got the space here, one section to wrap the Ethernet cable, and one section to wrap the power cord around. I designed the mount in several modules and designed a key to keep the front and back pieces aligned. Unfortunately, I didn't add enough of a gap when I designed it and the key didn't fit. Since I was only making one for myself, I just tossed out the key and aligned everything myself by eye. However, now I want to share my design so other people can use it as well. I went through the file and merged 2 of the bodies so there would be only 3 modules instead of 4. I removed unused geometry and cleaned up the file a bit. And then I started adding the new alignment keys. I played around with some tips from Slant 3D's video about making more robust alignment pins. I'm pretty sure I ended up combining a couple that weren't totally necessary to combine, but there will be a small shear force in line with the layers, which is not ideal, but I can't figure out a better way to handle it with the amount of time and brain power I'm willing to give to this project. Anywho, I drew a circle with a diameter of 8 millimeters and pinned it to the 45-degree diagonal at a somewhat arbitrary distance from the center of the piece. Close enough to the edge to make a small number of pins cover a reasonable amount of space, but far enough to add glue between the pin and the outer edge of the piece. I drew a plus sign in the middle of the circle with the width of the spokes at 0.2 millimeters to add strength by forcing the slicer to add more walls in this area. I extrude the pin to this plane I constructed earlier that's positioned halfway between the front and back of the front panel, which the corresponding opening will extrude into. I added a -1 degree taper to the pin to help it fit into the hole, and then I added fillets to the top and bottom of the pin. I started by creating 4 pins in a circular distribution, and then realized that if I do that, the pieces will have a symmetry that will make it possible to misalign the front and back pieces. So I switched to an uneven distribution of 3 pins, so the pieces will only go together in one way. Since there are 2 splits, I considered doing a different pattern on each split, but chose to match them so the middle piece can be left out or duplicated at will. I repeated the extrude on the second split in the model. I checked the length of the previous set of pins and it's 2.6 millimeters. For this one I rounded up to 3 millimeters, which I ended up changing back to 2.6 later when I realized the 3 millimeter pins breaks the intentional modularity of the system. And here, when I add the taper to the pin, I realize it was added to the cross shape in the middle as well, but I want the cross to stay as designed through the whole extrusion, so I go through the tedious process of adding all 5 profiles of each cross to each pin extrude, and then re-extruding the crosses separately without the taper. At this point, I decided to go ahead and carry the cross profiles into the main bodies for continuity. Again, this is probably complete overkill for this application, given the weight of the Hue Bridge, but that's what I did. I duplicated the fillets from the first pin on all 5 other pins, and now I need to cut the corresponding holes. I cut them with an extra 0.25 millimeters of diameter and an extra 0.25 millimeters of depth. I added fillets on the edges of the holes. Then I chamfered all the rest of the edges that will interface with the print bed and added fillets to round over exposed top edges and where larger shapes neck down to smaller shapes within the same body. I printed the new version in 3 colors just so you can see what I'm doing, and also because I printed it on 3 different printers to make it go faster. So they have these little knobs and they notch right in, And they're arranged in such a way that you can't get them incorrect. And then theoretically you could leave out this piece and then just glue these two together if you have like exactly the right amount of Ethernet cable or exactly the right length of power cable. I clearly didn't design it well enough to do that, but they're in the same spot. I just need to make these knobs on this piece shorter so that they interface with this piece, and I'll do that before I upload the file. Here's a look at the mount in action. I'm pretty pleased with it. If you would like to build one for yourself, check out the links in the description. I can hang the hub on the wall, maybe.